Okay, Jacek, so I believe we can start. So fasten your seat belt, my friend, and let's move forward. So good morning, good evening, everyone. We have a next Open Virtualization Pro webinar. And today my special guest is Jacek Skórzyński.
Hello,
Jacek?
hello everyone. Yeah, I'm here.
Yeah. Jacek is working from home, so unfortunately I cannot, grab him and ask the difficult questions. But no worries, I will try to do my best, via remote option via Zoom. Jacek, today option we'll discuss the dedup option and compression option natively in Red Hat Enterprise Linux called Virtual Data Optimizer, correct?
Yeah, exactly. Yeah, you are right.
So what was the goal for today's session?
Yeah, the goal is just to give you an intro because it's quite a while with us. I mean, this feature with RHEL, bundled with RHEL, so it's not an add-on, anything like that. It's just with single standard Red Hat Enterprise Linux. But I think not everyone is aware of this brilliant one, yeah, because it's a brilliant one. You need to admit. Okay. I hope all of you will admit that.
Yeah, I personally, met actually VDO or KVDO, depends if we're talking about the CentOS on the Red Hat Enterprise Linux version 2 years ago. And I'm really big fan on it, especially that it's inline deduplication that works by actually natively. Of course, we'll talk deep dive in a second. But definitely, like you said, not many people these days even still know that this option exists, and they're looking for the external options to have a dedup and compression methods without the knowledge about the VDO. So our goal for you today is to go in from the scratch.
Yes, exactly.
So from the zero to
give you like a jump start, like zero from zero to hero, I would say.
To the hero, yeah. So from the zero to the hero. So we prepared for you a few slides, and each slide will explain how the video works. But of course, Jacek prepared the live demo, so we'll go and deep dive how it's working through the installation. So from the scratch, from the zero to the hero, like Jacek said. So let's go for it.
Yep.
Few words about you, my friend.
Okay. Again, Jacek Skórzyński, solution architect at Red Hat. I'm passionate about, let's start from the hobbies, about volleyball and bike adventure. So whenever I've got a free time, I'm trying to be active, yeah. So a lot of activities, especially sports. And from the Red Hat point of view, I'm a senior solution architect, and my subject matter expertise is area is automation, but also everything around Red Hat and Red Hat's portfolio around infrastructure. So also RHEL and up to the cloud, I would say.
Okay, my name is Paweł Mączka. I'm a CTO and VP at Storware, and one of the founders of the Open Virtualization portal. So with the great experts such as Jacek, we're doing, talking about the many stuff related to the open virtualization from the Ovid perspective through the VDO, like these days. Personally loved playing my guitar, and I'm addicted to the backup and recovery platforms. So one of my business childs are vProtect, which are able to protect open source platforms like Ovid, for example. Okay, Jacek, let's go and starting from the scratch.
Yeah, let's have a quick intro to VDO. What is that? What is the virtual data optimizer from Red Hat? It's actually technology for the storage block virtualization with embedded compression and deduplication on the block storage level. So that's it in brief. But the history of that is at Red Hat starts when Red Hat acquired Permabit, a company which was responsible for the development of the software, and we were partners for quite some time. So starting from July 2017, we acquired Permabit and included VDO into the RHEL, starting from RHEL 7.5. So right now, anyone who is using RHEL, doesn't matter if it's a RHEL 7 or RHEL 8, you're able to use VDO inside your operating system.
Okay, I remember, and the key point is that the Permabit was quite successful in this area, but it was still a niche player.
Yeah,
because I think if you think about the deduplication, everybody is considering the Dell EMC data domain, for example, or the other say dedup appliances that are strictly related to the backup technologies. So in most cases, when we hear the dedup, we thought about the backup platforms and the backup appliances. Now, VDO is much more focusing on how we can help on existing infrastructure, not only on the backup side, but how we can use natively VDO on our OS system or on other applications in a daily basis, not only from the backup perspective.
Yeah, exactly. And from the benefits point of view, this, of course, the main goal, the main benefit for VDO is efficiency and cost reduction, and that's obvious. This gives us also an option to use our to make existing high performance storage more affordable. Why? Because we can put more data on it. Yes, so even with a relatively small amount of high performance storage using VDO, it gives us a huge boost. Then, of course, because the data reduction is applied on the OS, so that makes VDO working, that enables a VDO to work anywhere, basically. Yeah, so if you would like to use it on premise or in a public cloud or private cloud or hybrid, whatever, you can do it. Yes, because it's OS based. Wherever RHEL is able to be running, you can use VDO, basically speaking. And then because it is an OS level, so then all the upper layers, like applications, like for example, software-defined storage, can easily utilize VDO. And even before Red Hat acquired Permabit, we were partners, and we also had an option to include VDO that time as a Permabit software into the solution like Ceph and Glass. So we've got this today also, and so you can build your highly efficient software-defined storage with Red Hat from scratch, yes, from very bottom to the top. And the last thing is let's go back one. Yeah, is the copying of VDO volume, as it is smaller than the bandwidth which you need to copy your volume. Is you need basically less bandwidth, which is very good information when it comes to, for example, replication, which we're going to talk about it later on. Next slide. Okay, so how does it do? What the VDO, how it makes this whole thing about saving your data? So first of all, on the left-hand side, you've got this data, which are the mixture of real data, zeros, and all the things. The key point here is that we are working on 4 kilobytes data block, yes, and we cannot change that. This is fixed. So then having VDO, it gives us also an option for the thin provisioning. So we can set up a VDO volume, which will be like logically or virtually much bigger than you've got in your system. Then the VDO at the very beginning, when it comes to do the write operation, it eliminates 0 blocks. So by default, you've got the 0 blocks elimination for the as a first step. Then it starts the deduplication. So your data, your blocks are compared. There is a matrix which is index, which VDO holds also, and is responsible for mapping all the blocks which are deduplicated. Yes, so we do the deduplication, inline deduplication on the fly online. And the last thing is the data compression. Here it's worth to mention that you can online disable and enable it on the fly, your data deduplication and data compression whenever you want to do it. And so you can easily enable it and disable it without any problems with VDO. Next.
Important question is that you need to understand inline against the what is the inline deduplication. This is what the Jacek explained, is that everything that goes to our volumes are compressed, dedupe, and compared in a flight. So that's why we'll need more resources from the CPU perspective and the RAM perspective. Jacek will talk about it a little bit later, but it's important. We're talking about the inline deduplication. This is what we used to have in the external resources or external platforms dedicated to it. So it's a great opportunity that this inline deduplication is on VDO side. Okay. Where is my presentation? Somebody stole?
I didn't.
You didn't, for sure.
Yeah, it's here.
Okay.
Okay, let's go to the next slide. So there are several deployment scenarios, but the thing here is that the VDO should be put as close to the block device as it is possible. Okay? So there is a great guide actually about that, the admin guide, storage admin guide, RHEL storage admin guide, which explains it in details really. And having just this picture, it allows us to see that everything which is above VDO, it could be just a pure file system. It could be LVM, thin LVM, cache, or whatever we want to, even encryption. But VDO itself should be as close to the block device as it is possible. So there is, for example, not a good idea. It's actually unsupported to have an encrypted volume between and then put a VDO on top of it. Yeah, so we need to know those limitations. I will also talk about it a little bit more later. But the good guide for you, I already put some links to it, so we can you can take a look at it later on. And the thing is, let's go back one slide. I would like to elaborate a little bit more. Here we can do all the stuff like the duplication, compression on the object, on the block, on the file. So it doesn't matter what kind of storage you are talking about at the very end. If this is just self storage, or maybe NFS or Samba, doesn't matter for VDO. So you can do all those things with all the storage possibilities, yeah, all the storage systems. Next slide. Okay, so what's underneath? And it's quite important to know that the VDO is a set of 2 kernel modules. The first one, KVDO, which is actually responsible for all the compression, deduplication, and thin provisioning on the block storage level, on the block storage volume. That's the heart of it. The second one is UDS, and UDS actually holds the index of for the deduplication. So when we go to the demo, you will see that we've got actually a little bit less space at the very beginning available for us to be used when you compare just a raw file system. And why? Because of the UDS mainly. Of course, there is also a metadata for KVDO, but UDS mainly holds some piece of our volume for the index, for the mapping of the for the deduplication to be working.
So Jacek, it's important because we don't need to create a, let's say, dedicated database. Normally, when we have dedup appliances or dedup platforms, we need to have a dedup index or build the database separately. So I understand that everything will be put it on the same volume and put it in the right way. So we don't need to care about it. So the VDO itself will manage it.
Yep, exactly. VDO will do that job for us. And the key thing here is that it's not that, I mean, it's not that bad. You will see on my demo, because my demo is quite small. Yeah, I will operate on 10 gigs volume. So it's it's not a real life. It's not even close to real life.
Okay.
So that's why you will see that like 1/5 of this is consumed. But in the real life, when we are operating on terabytes, on multiple terabytes volumes, this is like up to 2% of your volume. Yeah, so it's not that big.
Okay, so let's deep dive and talk about the hardware and the hardware requirements, and then we'll go to the live demo part.
Yep.
Okay.
Okay, so from the hardware requirements, of course, the processor takes is one thing, but not the main thing from the VDO point of view. Of course, when you've got the multi-core, multi-thread processor architecture, which is normally which is usual, yeah, nowadays. You are able to tune your VDO system, your VDO architecture, just to be able for VDO to use as many threads as it is maybe not possible, but as you need. Yeah, so to make it as performant as your system can make it, and then. Of course, tuning for VDO is another topic, and we could spend on it like at least another webinar. But again, everything is quite good explained in the storage admin guide for RHEL, where you've got like a really big one, big chapter for that. From the memory perspective, could you please go back one more?
Mm-hmm.
The VDO needs, of course, some memory, and it's also tunable. But from the default setting, you need to have at least 370 megs for VDO itself, plus 268 megs per each terabyte of your storage. VDO storage, basically. Yeah, so we need to know that it requires some memory at the very beginning. Then also for the UDS index, a minimum is 250 megs of your RAM. Yeah, so it's not that big with no current machines.
So in short, if I have 100 terabytes that I'm planning to have 100 terabytes after the duplication. Of course, we need to remember that there is a dedup ratio, so we need to plan. I always saying that let's try to be more pessimistic here. So let's take 2:1, so 50% of the dedup ratio, 2:1 ratio. So it means that you can store 200 terabytes, and this 200 terabytes will equals to 100 terabytes. So 50% of the compression and duplication as a starting point. Yep. So if we have 370 megabytes multiplied by 100, then we need 37 giga of RAM on this particular system that's using the VDO. Yes?
Exactly, exactly.
Okay, so memory is crucial. From my best experience, the vCPU, it depends, but of course it's all about how much daily ingest you will have to this file system. But you can start from we always starting with the 4 vCPUs, but of course depends of the number of the sizes. But like
also, as I said, the tuning for it can give you more benefits. So not rely only on defaults, especially when you've got like a NVMe backend underneath, yes, which you can read and write like in multiple threads. Then tuning of the VDO in this case is for sure beneficial and worth to mention.
Okay.
Okay. And from the storage perspective, as I said, we've got as you said actually, Paweł, VDO takes care of everything. Yeah? So you don't need to worry about where to put my database or UDS index or whatever for the deduplication, for example. Yeah, everything is stored on the same volume which we put actually the VDO on, and those things are like it takes two main things like VDO metadata and UDS deduplication index. And for metadata, there is like approximately 1 megabyte for each 4 gigs of physical storage. Yes? So this is the calculation you need to know when it comes to the storage consumption of your VDO volume. And second, with the logical size is like every 1.25 megs for each 1 gigs is consumed from the logical point of view. Yeah, logical size, because you can have like a thin provisioned VDO volume. That's also something which I will show you during my presentation and the demo, and also UDS index. The really detailed data are put here in the storage admin guide. So I don't want to put too much numbers here, because I will not be able to. I will fulfill this presentation with just the numbers about the UDS index. So for those of you who would like to get more details about the storage requirements, I really encourage you to go to this Red Hat Enterprise Linux storage admin guide, where you've got plenty of scenarios and different numbers to compare, because it will vary between your I mean how big your volume is going to be. It will vary, and your UDS index will be bigger or smaller. Then when it comes to the operation side, we've got two main command line tools. So the VDO, which controls actually the VDO volume. You can create, you can delete, you can change your settings on fly, most of them. So this is what we use from the command line perspective to create, configure, and control your VDO volume. The second one is when we would like to know how many space we saved already. Yes, how many, what is our saving on this particular volume, and how many how much space actually I've got already to be used. Yes, I still have available. Yeah, so that's for that we've got a VDO stats, and with VDO stats we are able to get to know what is going on with our storage, and of course monitor it, yes, which is a crucial part with thinly provisioning volumes and also compressing the dedup volumes as well. So regarding use cases, there are few common use cases like VM workload. So for each of you who has an ability to play, let's say, with KVM machines, I really encourage you to check out how the VDO works with VMs. It's amazing. Yeah, you will get like really big amount of your storage free. Yeah, so that's really nice, and it really gives you an idea how it works and how much space you can save. The second thing is file sharing and archiving. That's obvious, of course. Yeah, so here you've got some on the right hand side bottom level, you've got some use cases and also implementation scenarios, which you can just take a look what you can do. Yeah, this is exactly the one about NAS or file sharing system. The third one, which is very common, is backup. But I think, Paweł, you can elaborate a little bit more about this this use case, as you're an expert for the backup.
Yeah, so, some of the people saying like this, but no worries. No, of course, this is what I said when we started, that the dedup is from the backup world, because in most cases we collect in most of the data and the numbers of the same copy, especially if we're doing the full once a time, once a week, once a month. So we can imagine that ideal inline deduplication will give us a great dedup ratio. And this is why we decided, for example, to use VDO in our Storware protected environments and the other platforms. So we use natively because all of our installation are going with the CentOS or the Red Hat Enterprise Linux. Natively, we've seen that we have a significant growth and the dedup ratio, significant growth of the dedup ratio, like 8 or even 10 to 1, if we're talking about grabbing the backups from our platforms. I believe, Jacek, also that the KVM hypervisors are also a great example, because many of the VMs are just the templates, all the actually the clones of the same base.
The same image, yeah.
Yeah, exactly. So if we have 200 of VMs, we can imagine that
a lot.
Yeah, we will definitely save a lot. That's why I said we always, when you're planning the dedup, take a pessimistic scenario that you will have 2 to 1. So 50% of your you will compress and dedup. So you have so you will spend you can double put the size of your storage then, but be quite sure that if you will put more data that are representing the same kind of the data, like I said, backups or the VMs, you will see more and more dedup saving on the VDO side. Okay.
Yeah.
2 last slides before we'll go to the live demo.
Yeah. So next one, and the one which you can see is the site replication and recovery, and the scenario with VDO and Gluster. So for those of you who are not familiar, we've got Red Hat has Gluster storage, which is an implementation of software-defined storage. But the special case for using the Gluster storage is Red Hat hyper-converged infrastructure. So you can put your, basically, you can put your virtual world as virtual platform, which is in this case Red Hat Virtualization / Ovirt, on top of machines, which can have like a two options basically. So those machines can be hypervisors and SDS at the same time. Yeah? So we equip those machines with spindles or SSDs if you want, and set up a Gluster storage on top of them. And those machines are also hypervisors from the REF perspective. And Gluster gives us also an option for the replication scenario. So we've got like a geo-replication option for Gluster. And as the Gluster is fully relies on RHEL, we can use VDO for the Gluster bricks to be deduplicated and compressed. Yes, so we can gain our storage from it. So that's why even async replication between both sides are not so extensive. Yes, so you can save the bandwidth. You can do it much often even. Yes, to make it work, which would be maybe from the other point of view not the case if you don't have VDO there implemented. Okay, so let's go to the demo scenario. So what I'm going to do, what I'm going to show you today is, as I said, a jump start to from 0 to hero. So I would like to show you first of all how to set up your video, how to make it work, how to deal with all this, maybe not all the settings, yes, but the default ones. Then verify how actually it works in a real life, how we can save this space, yes, how it does look like in a real life. And the third one is cockpit and VDO. So for those of you who are, I would say, Windows fans, and you would like to click through the GUI interface and make everything works, this is the point where you should really concentrate, because the first two are going to be dedicated for terminal fans. Yes, so the third one is next type of administration. Yeah? So that's what I'm gonna present. So let me share my screen. All right, hope you can see it now.
Yes, it's good.
Good. Okay, so let me go back to my scenario. So I've got here some scenario about how to work with the video and all the, just to avoid all the typos. I've got my machine, which is currently running on my laptop, actually. So this is just a pure KVM machine. I will put it down, and here it is. Yes, so I've got my video machine. What I can say, LSBL. Okay, and we will see that this is like a operating system storage, and here I already prepared first video volume based on some disk, 10 gig actually, which I've got, and I made it thinly provisioned. So it's thinly provisioned. I present to my system 100 gigs. And it's already mounted, yes. So MNT video 01 is there. So if I put df-h, I will get something like that. Yes. So this is already presented. It's empty, so there is nothing there. Okay, so just to start your video journey, what you need to do is to install your video. So basically, let's see if we've got our video already installed, and it is. I already did that just to save some time for syncing all the repositories and so on. And everything is working properly, so I don't need to take care about that. Yeah, so you need basically a VDO to be installed and KVDO module to be installed. Okay, so let's move on. Let's create a new volume. So I'll clear my already prepared some comment for that, and it's going to be a volume 03. Sorry for the typo. So I will create once again a volume from the VDA the VDA storage device. So if I lsb key k, this is my new VDO volume with 100 gigs thinly provisioned. Then I can do, I can put my file system on top of it. So I do it this way. Okay, we'll put it block size 4K. Okay, and I will make some directory to make it work and to then mount it with the discard option, just to make sure that every time I will delete something from my volume, as this is thinly provisioned, it's going to be discarded immediately. So df -h, I will get another volume, which is a VDO volume. Okay, so let's explore VDO stats. What we can get out of it. This is a basic VDO stats for my both volume 01 and volume 03. As you can see, let's put it into the human readable format. As you can see, as I warned you previously, we're gonna have only 6 gigs available space. Yeah? So we're gonna have like 4 gigs already used. And this is because of our metadata, and especially for the UDS index. But you don't need to worry about it. It's not that bad when it comes to the bigger size of your volume. So it's going to be that there are some calculations for the on that matter on the inside the storage guide for Red Hat Enterprise Linux admin guide. So you will be able to find out how many or how much space is going to be consumed each time when you're gonna do your VDO. As I said, my case, it's not even close to real life because I'm operating on the 10 gigs volume. So that's why it's a huge portion of the volume consumed for the UDS index and metadata. All right, then we've got some verbosity here. So you can see all the, stats from the verbose option for both of the volumes, as the write policy in my case is async. So it's good to mention that VDO can work in actually in 2 different modes, in synchronous and asynchronous modes. And also the default for the VDO should be an auto. It's a recommended. Yeah? So then the system will decide. With async mode, you need to pay attention to the battery or capacitor backed cache. If you don't have that, probably async mode is not for you. As I'm inside a virtual machine. That's also probably my case, but this is something which you need to take into account. Okay, so that's about creation of VDO. Of course, in a VDO create or VDO command has plenty of different options. So you can take a look at it later on. In your free time after our webinar, but today I'm going to concentrate, as I said, on the basics. So as I said, we can dynamically online turn on or turn off our deduplication or compression. So we can say, okay, I would like to switch and see what's the current status. So deduplication is enabled, yes, and compression. How about the compression? Compression should be also enabled. Yes, it's enabled. There is also another way to make it to check it with the files for the KVDO module. So you can okay, it's not my volume. It's VDO volume 01, it's online, and 03, it's online. Yeah? So you can see it here. Then when it comes to the disabling or enabling your deduplication, as I said, we can do it on the fly. So let's go here and see if I can disable that. Yes, I can. And if I go to the compression status, it's disabled right now. Yeah? So then I can also enable it, and the same for the deduplication for actually both volumes. Yeah? So we can say right now it's enabled again. So that's how we can do it with the online deduplication and compression, enabling and disabling during while the volume is online and it's working.
Yeah, Jacek, but when you see the reasons why we should disable the compression, the overloaded or the lack of the resources.
Yeah, this is the first one. For some troubleshooting, for example, that could be also something which you probably need that to do it on, maybe on the fly, maybe not. Yeah, but that's also another option.
But by default, I recommend that we should, keep the compression.
Both,
keep both. Okay, go on.
Yeah, by default is to keep both working. Okay, so let's now explore about this data saving mechanism, and let's prepare two volumes. One is going to be with video, and the second one is going to be without video. Actually, the other way. So I will create a non-video volume. First of all, let me do that, and mount it somewhere in this catalog. Let's say the catalog data. As I've got my notes here. Then we've got another volume. Okay, which is the volume VDD, should be empty. It is empty. So let's add another video volume for it. Okay, we've created that. Let's put some file system on top of it. And let's make a video data directory. Well, what I did, video data directory here. Good, and let's mount it with the proper options. Okay, so now if we go to say df-h, we should see our data here, which is just a plain disk with the file system, and video data here. Yeah, so here we've got like 100 gigs because it's I put this thin provisioning on top of it. With video, so it's a little bit different size. And what I've got just for testing, I put together some ISO image, which is 600 something megabytes, and I will do initial copy. So I will copy that into the my minimal RHEL.
It doesn't have rsync.
Doesn't have rsync. So let me correct that. I hope it's not gonna take too much time for us, and we're gonna have this rsync. I'm just trying to make everything minimal, so that's my default.
I hope you do not do it with the work, yeah?
No. Yeah. So let's let's take a look at it, and let's also make it work on the video device. All right, and here we're gonna also compare those two files just to make sure both are the same. Yeah, they are identical, and see what is the size of both. Yeah, so actually, as I shouldn't put this into this in provision, but it's more or less, should be more or less the same when you compare the used space and all the metadata from it. It should be more or less the same. But let's take a look at this, and let's try to create a little loop to fill the space on the data storage. So I will copy that a few times, maybe even more than just a few. So let me put it from 7 to, I don't know, 12. Should be enough to fill it
So we can imagine that if we have a full backup, for example, it's like the representation, the new template of the VMs. So in 90% it will be collect the same amount of the data and same set of the data.
Yep, exactly. What is going on with this storage? Is it so good that, okay, we need some more iterations. So let me do it to 25, and then it will for sure not make it. So let's fill it up. As we are currently copying this to the not deduplicated or without any VDO. Yeah, so we've got this already, the error that it's doesn't give us any option to copy more because it's full. So we will see it here, it's full. So let me do the same for the VDO based and let me correct that. So I will copy that and let's make 25 from the very beginning. Okay, so it will copy over and over for quite some time, but then we will be able to see this in-flight deduplication, because we are copying exactly the same test image. Of course, we are changing the name, but from the block perspective, it's the same. Yeah, so we're going to be able to see it, to see how it's working, and to hopefully see all the files, even if we don't have that much space here. Yeah, so it's like 10 gigs. Remember that this 100 is just a thinly provisioning. So in real, we have even less than 10 gigs, even less, because it's like 6 gigs. Yes, with all the video overhead and all the stuff which we've got in place on the volume, as we said, that there is a need for some space for metadata, for KVDO, and also as the huge portion of the space is reserved for the UDS index, for the deduplication operation. So my VM is it's not a beast, so probably it's right now consuming all the resources, as you can see here. So as I said, it's not even close to real life scenario, as this is just one of the CPU and 6 gigs of RAM. So that's why the performance is not doesn't impress.
It's not bad. No, it's not bad.
It's not that bad. Yeah. As for my poor laptop, it's still working. And
remember
like
that 10 years or 15 years ago, you need to go to the big data center to get these numbers on a demo site. So it's not bad.
And the thing is that also a good thing to know that with VDO, if you have like a multi-thread storage behind, so the like a real storage array, you're able to get like a pretty nice numbers. Yeah, so that's what I said about this multi-threading thing with VDO. All right, seems like we were able to put 25 or 26 even files on top of my video-based volume, which is only 6 gigs. Yes, because we've got this 100, which is thinly provisioning out of 10. But then we've got some overhead on top of the volume, and in return it gives us just a 6 gigs, and I was able to put all the files there. With a standard volume, of course, I wasn't able because I filled it up. So let's see the video stats and see what we've got here. So this is the second one is my video volume, which I just put some data on. 3 and 01, 03 and 01, those are just empty ones. Yes. So as you can see, I copied here like 25 images. Let me check that. Yeah, on data, I was able just to fit like 16 of them, and on the video data, I was able to put everything, and I still have like 5.4 available for my. So I consume just 6% out of 6 gigs. Yes, here on the physical layer. And so that I hope that that shows you the benefits of using VDO with the duplication and the compression enabled.
So please stop sharing, and we have a question. So how many of memory and vCPUs you have on your existing VMs just for the demo purposes?
For my demo purpose is 1 vCPU and 6 gigs of memories. Yeah, so it's
okay.
This is not the beast, as I said. It's just a tiny machine, and it works, as you can see, quite well. So and it resides on the laptop which I'm talking to right now. So again, it should not be that bad. Yeah.
Great. Tim, because we are actually limited of time. You said 1 hour, and I said no, we need to do it in a 35 minutes. And right now I know it's not possible, but we have a great demo and discuss a few scenarios.
Actually, Paweł, I've got one more just to fill up this 5 minutes which we still have.
No way. Okay, try do your best. 4 minutes. Go on.
Go. Let's share it. So for those of you who are terminal lovers, that was those 2 points, and I've got one more, which is for Windows style administrators or GUI lovers. Let me show you the cockpit. So I don't know if all of you are aware about the cockpit, which is built into the Red Hat Enterprise Linux again. So this is kind of like graphical user interface to manage your RHEL system. But we will concentrate today on storage. So having cockpit, I'm able to see all my volumes here, and I'm able to manage them. Yes, so I can see my video volumes, which I just created. I can see how many physical space I consume, how many logical space I consume, and so on. So that's the option. Those warnings here are just because I don't map it I don't put a proper configuration, proper lines to the FS tab, so it's not persistent. Yeah, so that's why it is here. But from cockpit, I can also create my video device. So having that, I can say that's this def VDF is the last one I've got, so I can specify here. I can say, okay, the logical size would be like, I don't know, 20 something, and my memory index for the UDS are going to be, you know, I can also tune it. Yes, I will leave it for just as a default, and I can easily create my new video volume, yeah, which is somewhere in here. I didn't put some meaningful name, but as you can see and should see, it should be already mapped. Or not, I didn't map it. I need to format it, and then I will be able to map it or to mount it permanently with cockpit. So
you don't have
everything what I did, everything what I did, I can do it through clicking inside cockpit.
Okay, so we have an option to do not only going through the command line, but we can use cockpit to, in most cases, to create and manage the video.
And even monitor them. Yeah, monitor your
and
device.
Even monitor them.
Yeah.
Okay, Jacek, thank you. That was a great session. We took actually the 1 hour workshop talking about the video and all of the benefits. And it's hard to, you know, to find any cons. It's only the pros and all of the advantages that we have, because everybody wants to save the data. We know that there is more and more data every day. Our business has generated actually the tons of the new data that we need to manage, we need to collect, we need to protect. So, but the way how we can use the video in our existing CentOS or the Red Hat Enterprise Linux, the way how we can use it definitely benefits everybody. That, you know, from the infrastructure point of view to the admin's point of view, to the cost point of view. So everybody should be happy when they have a video. And keep in remember, it's inline deduplication, which is not requiring the dedicated database. We have a UDS, which will be responsible for the indexing, and it's for free in every subscription or even the CentOS environments. So Jacek, thank you for your time. Thank you for the preparation, for your expertise. If you have any more questions, do not hesitate to contact us via the Open Virtualization portal. Thank you for your time, and Jacek, for sure, we'll see you on one of the next sessions. We need to discuss what topics we will choose.
Yeah, yes.
So thank you, everybody. Have a great day. Stay tuned. Cheers.
Thank you. Bye.